Okay, good morning everyone. I think in the last class we have discussed about the influence diagram for various loading pattern. Okay, for SSD, for SSB we have already did. After that we have did for point load and there is various condition for that point load. If there is a single point load, if there is a more than one point load, and also if there is a UDL. Okay, we have discussed about it. Up to that, is it clear to you? Is there any doubt? You can ask me, okay, or else we will move to the next.
Yes, sir. Sir, I have doubts, sir.
Okay, is it Michael?
Yes, sir. Michael, sir.
Yes, Michael. Okay, you can ask.
So, from all the calculations we've done.
Yes,
Hello, sir.
yes, sir. Yes, I'm listening.
Sir, can you hear me, sir?
Yes, 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 Michael. Carry on.
Sir, if you, all the calculations we did so far, sir, where shear force is zero, bending moment is also zero. But sir, shouldn't where shear force is maximum, bending moment is supposed to be zero, and when bending moment is maximum, shear force should be zero. But sir, in all the questions we did so far, why is it that bending moment is zero at the same point again shear force is zero?
For the calculation you were saying?
Yes, sir. Even the derivation we did
Yes,
in the diagram when we draw the influence line diagram,
yes,
shear force is always maximum at the support, near the support for simply supported beam, and bend moment is zero. And when bend moment is zero, shear force will be maximum. But sir, in all the things we did so far, bend moment and shear force they're minimum at the same point. So is there any reason, sir?
yes, yes. You see, we are when we are considering the moving load, that you are saying is for dead load. Okay, when we are considering the dead load, that condition is there. But when we are considering moving load, now we are what we did. We are finding out the diagram and the impact of that load in a particular point. In our case, we are considering any particular point, say C. Okay. In our case, we are considering a particular point C. In that particular point only, we are doing what is the impact of that. And for that, these are the standard condition. Whatever we are doing in the derivation part, these are the standard condition given by already given by some what I can say some researchers. Okay. So that is the standard derivation. Okay. What we did. Let me show you. See what we did in the derivation part. So see these are the standard condition, okay, for this type of loading pattern. Okay, so whatever we are doing, we are considering about this point only. Let me show this point, impact of all the loading on in that particular point. Okay, so for that we need to follow this only, these conditions. These are the different condition. So for this condition, we are considering this in that point. What is the loading? What is the impact of that particular load and all these things in that point? Okay.
Oh, okay, sir. We're only finding the maximum shear force and bending
Yes,
moment
yes,
at a
yes,
particular
yes.
point.
We are considering only for that point.
Okay.
See these figures also. These figures are all standard
Yes, sir.
figures. Okay, everything will be same. Only when we consider the point load, no need to consider this area. Okay, this area we have calculated the shaded portion. But when we consider UDL, we have to find out that area, because in the last class I have explained you how we need to find out that area, this area, trapezium area. We need to find out for that UDL. Okay, these areas we need to calculate. And again, see that same thing will come because we are considering this ordinate. But when we did earlier, considering dead load, we are not supposed to find out this ordinate and all these things. Okay, we are simply following that our basic things by taking out the reaction, by multiplying, simply by following the steps. We are finding out the shear force and bending moment at a particular point. But this time for moving load, for UTL or for moving load, for finding out the ILD, we need to follow this pattern. We need to find out this FC at that particular point. See, at that point only we are finding out FC, MC. At that point, what is the maximum shear force? What is the maximum bending moment? After that, we are finding out that ordinate. We need to also calculate this ordinate so that we can add this ordinate or if there is UDL, we have to find out also this area, so that we can add that value also with that load, so that we can finally we come up with this. What is the SF? That point. See this point. SF and bending moment at that point only. Similarly, when we consider this point load also, in the earlier case also, see FC, we are finding out MC, we find out, after that we find out that ordinate Y1, these things, Y1, Y2, these things, Y3. Okay, after this again you need to find out this, you need to put in these formulas. Okay, for this particular case also, when we are considering more than one point load, we need to consider this diagram, and similarly we need to find out this ordinate. Similarly, when we find the bending moment, we need to find out this ordinate, and we need to follow these two formula, this and this. Okay, here up to SF is showing, but after that also you need to find out that bending moment also. Okay, so today what we do it, we will discuss a example including both these two, point load and UDL, how it look like if the both conditions is there in the same particular question. Okay, earlier we did for point load and UDL, now we are going to solve a numerical. See here, point load and UDL is also there. Okay, there are 3 point load and 1 UDL is also there in that particular beam. Okay, so what we need to find out, how we need to find out, let me explain you, all of you go through this. Okay, again you need to find out that ILD at a particular point. See, you can consider this point at anywhere. Okay, but for our easy calculation we are considering at a equal distance. Okay, so see, again same way we need to find out this FC, this FC maximum shear force at that point, this point, at that point, this point C. Okay, what is the total length? We need to find out 2 meter, 2 meter, 2 meter, and 4 meter. So total length of our beam is L is 14. Okay, Z is nothing but the distance of C from the support A. If we are considering this as A, so at a distance of 4 meter, this is our Z. Okay, so just simply put the value, you can easily find out the FC at that point. Okay, remember this formula, these formulas are the common formulas. Okay, these are the standard formulas we need to use. Similarly, again we need to find out MC at that point C by putting all this value L, Z, everything we know. Just we need to put these things. Okay, so now what is the difference between the earlier one and this one? Here you see, here there is 3 point load, 1, 2, 3. For this there will be 3 ordinate will come, but for this UDL also there will be 1 UDL will come. Here you see Y1, Y2, Y3, Y4. We need to consider at the starting, and the ending point of this UDL. This UDL. Okay. For this point load is applied, and here we need to consider 1 ordinate. Here I have drawn this. You see this drawing. Y1, Y2, Y3, Y4. So similarly, by using similar triangle formula, you need to find out this Y1, Y2, Y3, and Y4. Okay. Kane Akash, please mute your mic. Okay. Okay, fine. Let's continue. So after finding out this Y1, Y2, Y3, and Y4, similarly again we need to find out this Y1, Y2, Y3, and Y4 dash. Okay. For that you need to draw a diagram like this. Like this, you need to draw for the bending moment. From here you can easily find out this 4, Y1 dash, Y2 dash, Y3 dash, Y4 dash. But one more thing is there. See, when we finding out that SF at C. Now what we need to do, we need to take the both condition as we did earlier. Okay, when we did earlier, we should, there is a point load, we are simply multiplying that y1, y2, y3, y4 with the load. Okay, but this time there is a UDL also given along with the point load. So for that, this extra portion will come. In the second part, there will be the area will become for the UDL. Okay, so we need to consider that UDL for that area. So again, by following trapezium area, we need to find out as earlier we did when we calculate the area of a trapezium. Similarly, we need to do for the UDL. There will be two, this for the UDL, this portion and this portion you need to shade it, and this shaded portion you need to find out the area by considering this trapezium and by considering this trapezium in the above portion, this trapezium. Okay, so for that there will be two area, a1 and a2 will come. Similarly, y3, y4 you have already calculated. Just put all this value, you will easily find out the SF. Up to this, is there anyone have any doubt? You can ask me. Okay, excuse me. Anyone have any doubt up to this? Okay, let's continue. So similarly, when we are calculating the bending moment, see this bending moment at that point C, here also for that UDL, this area will come. This area will come in that for that UDL. Okay, we have already calculated this y1 dash, y2 dash, oh sorry, y3 dash and y4 dash. See in this diagram for this y1 40 kilonewton. Okay, our y2 will be the representation of this UDL 10 kilonewton per meter and 60 kilonewton for this, the coordinate will be y3, and for 80 kilonewton the coordinate will be our y4 this. So and this sign also, here you see here we are using some sign. Before y1 it is minus, a1 it is minus, it is as per this figure. Okay, if it is in the lower side you should use minus, if it is the upper side it should be positive. Okay, so similarly, when we are considering the bending moment, again we need to consider that UDL. For that UDL, we need to find out this area for that UDL. In the bending moment diagram, there will be two area, A1 dash and A2 dash. Again, by trapezium, we need to find out the area of the trapezium, particular trapezium. We need to put that value. You can find out differently, or you can simply directly put in this formula also. As here you can see, it is directly putting here these values. Okay, or else you can also do it earlier by another step. It's up to you how you can find it easy. You can go for that also. Okay, see here it is showing how we need to find out this y1 dash, y2 dash, y3 dash, y4 dash. So after finding all these things, just putting all this value at SF, you can easily find out this area. There you see everything is done. Okay, till now is there anyone have any doubt? All of you please try to do one. Okay, one numerical by your side by considering any load. You can just take the example like this, like this. One example you do, you take and try to find out. You can consider this load a different load also. Okay, in place of you replace the load by your own, any load you consider and try to do, and you need to draw this. Okay, remember you need to draw this. The representation will be same. You will get the diagram only like this. This is SF diagram, this is bending moment diagram for this type of loading. Okay, only is the difference. If when we consider point load, no need to consider the area, because it impact of that load in a particular point only. Okay, as you can see, if there is a beam, if there is a point load like this will affect only in that point only, in this point only. Okay, but when we take a beam, and if there is a UDL like this, so what is the impact? It impact will be in this particular area of that beam. That's why we need to find out the area. Okay, so all of you please try to solve this numerical. Okay, this is the same as earlier we did this one. You see, this is the same as this, only you replace the load with different load. Okay, just replace this load, this replace this load. This is the representation of this only. Okay, this figure, this question. Finally we need to draw this. We need to put all the value here, whatever we got, L minus Z, this L minus Z by L, y1, y2, y3, y4, whatever you got, just you need to put this here in place of this y1, y2, y3, y4. Similarly y1 dash, y2 dash, y3 dash, y4 dash. Just write the values here, and in the below of this figure and this figure, you write, simply write this ILD for FC, or this is ILD for MC. Means maximum shear force at the point C and maximum bending moment at that point C. Okay, this is a very simple thing. Okay, very simple. Just you need to remember this formula for finding out shear force. You need to remember two formula. One is for the above part L minus Z by L, and for the below part it is simply minus Z by L. Okay, and for the bending moment also you have to remember only one formula, L minus Z by L into Z. Okay, so that you can find out FC and MC. After that, by considering equal angle triangle condition, you have to find out all the coordinate for the this one and for this one. You need to find out the coordinate y1, y2, y3 and y4. Similarly for this y1, y2 dash, y2 dash and y4 dash. Okay, so this is the sim. After finding out these things, if there is only point load given, you simply put SF at C is equal W1 into Y1 plus W2 into Y2 plus W3 Y3 plus W4 Y4. Okay. In case of point load, if there is only one point load, only one part will come. If there is more than one point load, according to that, all the part will be added. Okay. As there is four loading pattern, so we have to add W1, Y1, W2, Y3, W2, Y, sorry, W2, Y2, W3, Y3 plus W4, Y4. But if there is UDL given, you need to check in which portion is UDL is given. Okay. So for that portion, what you need to do, you need to consider that whole area. So for that, again, what you need to do, you need to find out the area. Okay. So for that, finding out that area, you have to check how the structure will look like. So in our this particular type of structure, as you can see, these things, and these things here also, this part and this part, it look like a trapezium. So you have to follow the trapezium to finding out the area of that particular portion. So after finding out that particular portion, you need to add according to the given load pattern. So where it is given, it is in the here it is given. So it is given in this portion. So for you need to consider with the W2 load. See, with the W2 load here also and here also, you need to consider area this area. And for the other remaining part, only simply multiply W1 Y1, W2 Y2, and W3 Y4 like that. Okay. For bending moment also, simply multiply with the coordinate. But if there is UDL given, you need to consider the whole area where the UDL is applied. Okay. Is it clear to you? Okay, fine. Our next part is a different topic, so we will not start today. We will discuss in the next class. I will also give some notes from the books to you also. All of you, please go through this. Okay, if you feel any doubt, you please come up with that in the next class. I will try to clear your doubt as much as possible. Please go through this once and give your attendance in the while in the start talk also. Okay, is there anyone left to give the attendance? Please quickly give. And is there anyone have any doubt? You can ask me. Okay. Okay, then everyone, all of you please go through everything, whatever we did up to this today's class. All of you go through once and try to solve by yourself some numerical. If there is anything, any confusion you will get, you can ask me. Okay. In the next class, all of you please come up with that if you have any doubt. Okay, then we'll continue in the next class. Thank you all. Okay. Thank you.